evaluate this line integral over c of y squared dx plus x dy, where in part A, let's begin there, c is the line segment from the point P, let's call this minus 5, minus 3, to the point Q, which is the point 0, 2. Okay, so first thing we want to do is parameterize this line segment. And so for this, we get 5, 5 as our vector. Okay, and so to parameterize this line, we've got r of t is that vector, PQ, times the parameter t plus one of the points. Okay, and so if I just choose the easy one, q, then we've got plus 0, 2. Okay, so our parameterization here of that line segment is r of t is 5t, and then 5t plus 2 for t between minus 1 and 0. All right, so in the next part of this, we want to look at the y squared and the x and form a vector f from that. So let's say let f be equal to y squared x. Okay, and then now the integral over c of y squared dx plus x dy can be expressed as a dot product of the vector f with the vector dx dy. And so this is the integral over c of f dot dr. So from minus 1 to 0, f of r of t dot dr on dt dt, which is r dash of t dt. This is the integral from minus 1 to 0. Now f of r of t, what we do is we take f and put in our parameterization in for the x component and the y component. So that is 5t plus 2 squared, and then 5t, and then we dot this with r dash. So r dash here, just differentiating r with respect to t, we have 5, 5. Okay, now taking this dot product, we have 125t squared, so 100t plus 25t is 125t, and now we have 4 times 5 is 20 dt. Okay, let's integrate this. So 125 over 3t cubed plus 125 over 2t squared plus 20t minus 1 to 0. Okay, when we sub in 0, we get 0. So we've just got 0 and then minus in brackets 125 over 3 times minus 1 cubed, which is minus 1, plus 125 over 2 minus 1 squared is 1. And then 20 times minus 1 is minus 20. Okay, so simplifying this, we've got 250 minus 375 plus 120 all over 6, which is, so minus 5 over 6. And